Okay, we are here as part of the ICQ YouTube channel in our regular series of interviewing comet people and people who are connected with other things related to comets, such as meteors, meteoroids, and things like that. We're here to talk with Kacper Wierzchoś today, who is at the University of Arizona, and he works with the Catalina Sky Survey, which is currently the second most prolific discovery survey of comets after Pan-STARRS. So we are very eager to talk to Kacper, who seems to me to be the biggest comet person at the Catalina Sky Survey currently. And so the first thing I want to ask you, Kacper, is just for our audience to tell them how you pronounce your name in Polish.
Yes, so in Polish, my name is pronounced Kacper Wierzchoś. But for English speakers, Kacper Wierzchoś, that's fine, works fine. I'll go by either.
Okay, very good. So Kacper, please tell us a little bit about your early life, where you were born, where you grew up, where you went to school, and how you became interested in astronomy generally and comets specifically.
So I was born in 1988 in a city in eastern Poland called Lublin, but ever since an early age, I lived in Spain. My parents relocated to Spain, and that's where I went to preschool, school, high school, and university. So how I became interested in astronomy and comets. My earliest memory of, let's say, my earliest astronomy related memory is also, it also happens to be a comet memory. I remember I was a kid and we were driving somewhere. I remember my dad and my mom were in the car, and my dad stopped the car on the side of the road. It was some rural area, and he showed me this like little V-shaped light. It was close to the horizon, and that light was obviously Comet Hale-Bopp, and that made a profound and lasting impression on me. I sometimes try to think, what was it about it that impressed me so much? And I think it has to do something with that primal idea that comets should not be there. You know how throughout millennia people have been scared of comets. They've been bad omens and things like that. So there was something about that to my, I don't know, like 8-year-old brain, it seemed that light should not be there. And that, of course, piqued my curiosity. So, well, my dad probably at the time explained to me what a comet was. I don't remember. But yeah, that was my first astronomy-related memory. So as I grew up, when I was in my early teens, I became quite interested in astronomy. I was, I guess, what you could call a curious child. My dad is a scientist, even though he's a chemist, but he was very supportive of me being, I guess, a scientist or a curious person. I remember when I was young, he would bring all sorts of flasks and liquids for like chemistry experiments, trying to, I guess, make a chemist out of me. Didn't quite work out. And yeah, at some point I got a telescope for Christmas. It was a 90 millimeter Maksutov Cassegrain, the MEET ETX 90. And from that point, it was all astronomy for me. We'll go out at night and find all the Messier objects. Yeah, it was great. I did some astrophotography. So even though that memory of Comet Hale-Bopp stayed in my mind, right now it was mostly just like astronomy, just the universe, the whole scale of things that incommensurability of things. I don't know why, but it just fascinated me. So then I would say another cometocentric, comet-related event that happened in my life was in 2000, I believe it was 2004 or 2005. My high school teacher, Anicet Kosials, and two high school friends of mine, we submitted a project to a contest, a high school contest. And what we did is we basically measured the size of the planet Venus during the Venus transit. So obviously using basic trigonometry. But I had a camera that I attached to my telescope. It was, in fact, it was a webcam that was modified for astronomical use. It was called the Philips Tocam Pro. And I remember that modifying that camera, I broke the first, but the second one turned out okay. So we took images of the Venus transit and made a little high school project, and the high school fair was held in Granada in Spain. And somehow, I don't know how or why, Richard West, discoverer of the great Comet West, was there, and he was giving a talk at that high school fair. And he was really the first professional astronomer that I ever seen or met. So I went there. I was like, so that was 15, 16, introduced myself. And he was a really interesting person, really knowledgeable, really intellectual. And he made a very strong impression on me. I was like, wow, you're like the person who discovered this comet that I read about, you know? So I was like, you know what? Maybe one day I could be a professional astronomer and also discover comets. That would be a really cool thing to do. So, you know, I was young. I had all the time, you know, in front of me to pick a career path in my studies. So I just went for it. Yeah, I went for it. Then when I was probably around 18 or 19, I got a larger telescope, an 8-inch Schmidt-Cassegrain, and I started doing astrometry of minor planets and also comets from my parents' place in Madrid. I got the MPC code J20. But the light pollution was very, very, it was very strong. You know, Madrid is a major metropolis in Europe, so it wasn't easy. But I still got to observe quite a few comets and submit astrometry to the Minor Planet Center. And at some point, I even got astrometry of 2008 TC3, the first impactor, which was discovered by this man called Richard Kowalski at this place in the United States called the Catalina Sky Survey. So I was like, okay, there are all these comets called Gibbs, Christensen, Kowalski, Larson, Bottini. So I'm like, all of these people seem to be at this institution in the United States, and like, how cool would it be to, you know, visit them and meet all these people someday, you know? And, you know, then I finished college, bachelor's and master's in applied physics. So when I applied for a PhD, it was in the US. And of course, it had to be about comets. So yeah, here I am.
Okay. That's very interesting. So what was the second comet that you saw after Hale-Bopp? Do you remember?
It was one of the comets that Don Machholz discovered. It must have been 2004, the one that he discovered visually in 2004 with his 6-inch reflector. I forget the entire designation, but and fairly certain that that was the second one.
Okay. So was your second comet a visual observation, or were you doing? You
No,
weren't doing CCD
no.
then.
No, it was CCD. It was
CCD,
with
okay.
yes, it was with I took images of that comet with the modified webcam.
Okay.
Yeah, it was a webcam, but it has a CCD chip, and you could do an electronic modification to tweak it in order so it's able to make long exposure, because normal webcams don't do that. And CCDs were very expensive, so that's like early 2000s, 2004. So CCDs, yeah.
By the way, I think that comet was the one Don discovered at the Riverside Telescope Makers Conference. I saw it the night after that discovery.
Yeah, Kacper, you went out to the ranch there, right, and met Don Mackles?
Yes, that was absolutely, that's a wonderful memory that I have from going there and visiting Don and his wife Michelle. It was quite literally 4 months before he passed away. Yeah, but it was great going there and meeting him. You see, I had this book called The Cambridge Guide to Astronomical Discovery. I believe the book is
Bill Miller, right?
Yes. I believe the book was written somewhere in the late 90s, and it presents some methodology for discovering comets, supernovae, asteroids. You could call it outdated, but in that respect. But the real gem in that book for me are the write-ups by different comet discoverers. So you have people like Don Mackles, Minoru Honda, Caroline Shoemaker, David Levy, all these Mike Rudenko, all these discoverers, and they say they tell you kind of like like what their methods are, how they do it, mostly visual comet discoverers. And I was like fascinated by that. I was like, look, like these people are like finding comets with their telescopes, and sometimes they even show pictures of those telescopes, And I remember in the write-up that Don did for that book, he has this picture of his 5-inch, 127 millimeter binoculars that he himself built. So whenever I went to his to his ranch, he was like, okay, would you like to look through any of these telescopes? I was like, yes, that one, and also that one, and that one, and that one, I kind of wanted to see, experience like those optics, look how it was, that at least, like look at some messier objects, with some of his telescopes.
So as your interest in comets and astronomy grew, especially after you said high school, were there any like local astronomy clubs that you kind of joined or got, tidbits and ideas? Like, jumping into NPC astrometry, how did you even get started in that?
Yeah, so there was this Spanish astronomy publication, it's a monthly magazine. It still exists. Now it's called Astronomía. It used to be called Astronomía Universo. And there was an article about the fact that with a telescope and a camera, which I had, you could observe thousands, if not tens of thousands, of small bodies in our solar system, including comets, and you might even discover a new one, So I was like, this sounds interesting, But still, the amount of information that the article had and the internet and, for a teenager, it was still a little bit, you could say too much, But there was a group of Spanish expert amateur astronomers, Ramón Naves, Gustavo Müller, Julio Castellano. So those folks were doing CCD astrometry. Some of them started in the 90s, So that was like really a long time ago, where few people were doing it. Their MPC codes are 3 digits without letter. That's how you know when someone has been in business for a long time. So I got in touch with them, and we had this Skype calls going on, like a group Skype call. Skype existed then, so we'd set up and observe, do astrometry. So they guided me, especially in the use of Astrometrica, which is the software that I use. So yeah, they helped me during the time to have my observatory set up. And that's really the only group, kind of like that I work with. I mean, doesn't have like a formal name, as far as I know. I do have 2 friends in Spain. They're more or less my age, and we were in this together. We all had a telescope, and we would go, all 3 of us, drive somewhere at night, and observe. But I've never like formally belonged to an association or a group. And I have to say that is probably by choice. I know this might sound weird, but the way I understand astronomy, the way I enjoy astronomy the most is where I'm by myself with my telescope, I don't know why. I just like it that way, me, myself, my telescope and the night sky, and see what I find, see what happens.
I completely understand that sentiment.
I think we can all relate.
Yes.
So you have done some visual observing lately. So it sounds to me like you did not do much visual observing from Madrid when you lived there because of the light pollution. But when you got to Arizona, it sounds like you've been doing some visual observing.
Yeah. Whenever there's a brighter comet, I try to observe it and visually submit my estimates to COPS. I did submit some of my estimates. I remember back in 2016, whenever I moved to Tampa, Florida, where I made my PhD, and I remember sending them to you then, and they were included, in the ICQ. But yeah, I love visual observing, and lately I'm getting again into variable star, visual estimates of variable stars. I'm enjoying that quite a bit. To be honest, I maybe did more visual observing before joining CSS, for some reason, because now with CSS, I work at night, I have access to the sky, through computers, I shall say, and cameras, and I miss that part. I miss that, eye at the eyepiece, that purity and that experience. There's something magical about it. And unfortunately for my pocket, I really like really wide field immersive eyepieces, So yeah, I do that. But now with the monsoon, of course, that just started in Arizona, I won't be doing it for a few months.
What kind of equipment do you use for your visual stuff?
So I have a 12.5-inch Dobsonian, an Obsession. I have a 5-inch Takahashi Newtonian, it's an f6.3. I have a 4-inch apochromatic f7 refractor, and I also have a 7x50 binoculars. So a good range, I find myself using the refractor the most lately, perhaps due to aesthetic reasons, aesthetics at the eyepiece, how pure and crisp the image is. But I love binoculars as well, just doing like mini I call it mini Messier marathons, so every Messier object that's above the horizon, being able to, locate it with binoculars,
Yep.
and I do it, and then I'm satisfied, like I'm still in shape.
That was something that Don Mackles was very well known for, the Messier Marathon.
So, Kacper, prior to becoming a professional, did you do any visual comet hunting?
I did. I always did it without getting my hopes up, though. So I did scan the sky at low solar elongations, but I will also go into higher solar elongations because I knew I would find more deep sky objects, like more, how Leslie Peltier calls it, more wealth than Croesus could have himself imagined, right? When Leslie Peltier describes what comet hunting is about. So I did it, but without being obsessed about it, and without having too much hope. It was more about learning the sky, learning, as much NGC deep sky objects, their positions, as much of course, of the Messier objects. I would say that was my biggest factor, just going there and see what I find on the eyepiece, and stumbling upon some cluster or nebula, and it's like, wow, I didn't know this was here, and then going to the charts and trying to see what it is. And yes, I actually have brought my telescope, more than one, my telescopes to the observatory to Mont Lemmon, because we have an amazing eastern horizon without any light pollution. It's beautiful, and we're very high, so we can see very low into the eastern horizon. And since the night officially ends roughly about an hour before sunset, that's when I close and stow the telescope. I do have some time to look at those low solar elongations with the Dobsonian or any other telescope I might have at the mountain.
All right, let's talk a little bit about the University of Arizona's program that searches for minor planets, near-Earth objects, and comets. There are numerous telescopes that are used at different observing sites. Maybe you can walk us through a little bit about why there's a Catalina Sky survey, a Mount Lemmon survey, a Bach survey, and we have a lot of the people are overlapping, right? You have a lot of people working in the group that use the different telescopes, but they're relatively close to each other there in the Tucson area. So maybe you can just talk us through a little bit about how many telescopes are used nightly on average, and how many observers work with you now.
Yeah. So I'm not surprised that there is some confusion, because the Catalina Sky Survey started with one telescope, which is the Schmidt on Mount Bigelow, MPC code 703, and over the past 20 years. Or more, 25 years, it's expanded, it's grown quite a bit. So we now have several different facilities. So let's start with the survey telescope. So the Catalina Sky Survey telescope, it's what's referred as the Schmidt. In the group, we call it the Schmidt. As I said, it's got the MPC code 703, and that is a survey telescope that can cover lots of sky, but only down to magnitude 20 if it's a really dark night, no moon, good weather. And with that telescope, we're able to cover the entire observable sky from our latitude. Once every 3 or 2.5 days, depends on what the moon is doing. If the moon is bright and it's in the middle of the sky, then of course we have to skip that, call it the moon exclusion zone, so we don't observe there. So roughly the entire sky every three nights. Then we have our other survey telescope, which is our flagship. It's what we call the 60 in the group. It's what people know as the Mont Lemmon survey, and it's got the NPC code G96. That telescope is at the summit of Mont Lemmon, just at the summit. It's got 60 inches in diameter, or 1.5 meters. And it's got a smaller field of view. It's got 5 square degrees versus 20 square degrees at the Schmidt. But it can go much, much deeper. We're talking about magnitude 22 on a good dark night. So with that telescope, it's not unusual to discover several NEOs in one night. I believe there's one observer who has the record this year. She discovered 51 NEOs in one sitting, in one night. So that's a lot. And yes, that is our flagship telescope, and it's also the telescope that we use the most for discovering comets, even though comets are a byproduct of what we do. As we all know, we're a NEO survey, but we're here to talk about comets, right? So yes, that's our flagship. Then there's a third survey telescope that is a collaboration between Catalina Sky Survey, Spacewatch, and the University of Minnesota. And that is the Bock telescope, which is located in Kitt Peak. It has 90 inches of aperture, 2.3 meters in aperture, and that telescope can go very, very deep. I believe the faintest NEO that we found with that telescope was something like 23.8. Ridiculous, very, very, very faint. And also 30-second exposure. Of course, it has a much smaller field of view, and the telescope is it's not optimized for this type of work. But last year we were able to get into the 3-digit territory of NEOs discovered per year, so well over 100. The Schmidt also discovers roughly about 100, and then the 60-inch Mont Lemmon probably about 1,200. Depends on the year and what the monsoon is doing. So that is for survey telescopes. Now, and I should say that the Bock on Kitt Peak, at collaboration with Spacewatch and the University of Minnesota, we use it about 9 nights per lunation, 7 to 9 nights per lunation. So it's not how we would say, it's not like hours. It's also
not fully dedicated like the other two are.
Exactly. It's not fully dedicated. Then if we move to follow-up, we have the 40, or how most of us call it, the 1 meter NPC code I-52. And that is a telescope that is literally next door to the 60, to G96. So it's at the summit of Mont Lemmon. And that telescope, well, it's a 1 meter reflecting telescope. Last year, we had a major upgrade. It used to have a Cassegrain focus only, but now we've totally removed the secondary, and now it's a prime focus only. So much faster and better instrument for the type of work that we do. And it's a telescope that is dedicated for follow-up exclusively. Follow-up of near-Earth objects.
So that's full-time for your survey as well.
Correct. That's full-time CSS follow-up, and it's for follow-up of either objects that are on the NEO confirmation page, or sometimes for objects that what we call single apparition NEO, so objects that were discovered few apparitions ago, and there's certain degree of uncertainty to their orbit as of now, so try to recover them. And then we also use about 7 to 9 nights per lunation the Kacper telescope, which is next door to the Schmidt on Mount Bigelow, and that is a 61-inch telescope. The camera is on a Cassegrain focus, so it's quite a long focal length. And that telescope, we use it also for follow-up of NEOs. And of course, we use it for objects that are fainter, that are dimmer, but that also have a smaller uncertainty. So the way it works is but there's a few more people who are in the daytime crew who are also trained as observers, so they can jump in if needed. And we're all trained to use either telescope, rotate. Each telescope has its personality and its quirks, its funny things. So we want to stay current in all of them. So, might be that this lunation I might observe only at the Schmidt, and the next one just do follow-up and also duty at the 60. So yeah, that's kind of.
So how much are you able to do remote observing, or are you on the mountain for some of it? How does that work?
So the only telescope that currently supports remote observing, and that is by design, is I-52. That is the 40-inch or the 1 meter. That's one of the follow-up telescopes. For the other telescopes, we are at the mountain. So the Schmidt observer is there all night working at the control room, and there's a dorm. Same for the 60-inch, there's a dorm. And the 1 meter can be run from the control room of either telescope. Sometimes happens that, someone might get sick or vacation or short-staffed or whatever the case may be. So you may end up running 2 telescopes. It's usually one of the survey telescopes and the 1 meter. It even has happened that someone has run 3 telescopes in one night due to 2 people getting sick. That is a challenge. Really busy night, but it happens. Yeah, so we want to have someone at the mountain. You know how it is with telescopes. There's always something some shutter that needs to be power cycled, some dome that needs to be, gently. It works that way with telescopes. So whenever the 1 meter, which is operated remotely, needs some human intervention, then the person next door at the 60-inch goes and does that. Same for lighting shutdowns. When there's lighting, like right now, all of our telescopes are in lighting shutdown. The person working at the 60 would have to go and do a lighting shutdown at the 1 meter and then also at the 60.
So you said Catalina and Bigelow are right next to each other.
Monbigelow, I guess Monbigelow is the name of the mountain. So the Schmidt and the Kacper are next to each other, and that is called Catalina Station. There's only 2 domes. It's only 2 domes on that little mountain. 2 domes.
But where does the name Catalina come from if the name of the mountain is Bigelow?
Well, from the Santa Catalina Mountains is the name of the entire range.
Of the range.
The range of mountains, yes.
I got it. Yep.
Yeah, it's a big range that, you can see from anywhere in Tucson. It's the Santa Catalina Mountains, yeah.
Got it. Okay, so Mount Lemon's part of the Catalina range.
Correct.
Okay.
Yeah.
Okay, you've talked a little bit about this as far as it sounds like there is follow-up when you have a comet suspect. Can you tell us a little bit about whether that's done just for astrometry or deep imaging?
So the way it works is, so imagine I'm operating one of the survey telescopes, and I spot a comet, right? In the images, I'm like, okay, I have a moving object, and this thing clearly has a comma and maybe a hint of a tail, right? So usually, me personally, I drop everything and start typing the report, like in the communication line, just, high-level description of what I see, send it, and then I don't have to worry about anything. And then if the object has a digest 2 score higher than 65, that is, in other words, if the object has a probabilistic score higher than 65 of being a near-Earth object, then the object will land on the NEO confirmation page. And then we would tell the follow-up operator, because we all of us CSS folks who work, we're in constant communication via Slack channel. We have a chat channel going on. It facilitates matters a lot in terms of operations and being effective. So we will be like, hey, I sent this guy as a Comet. Can you please give it an extra, exposure, just so if that person also sees it as a Comet, they can send an activity report, right? So it's, of course, it's mostly astrometry, but we will be like, hey, I think this might be a Comet. Heads up. Can you go?
So you're messaging your other team members who might be on another telescope and asking them to look as well.
Well, that's after it's been sent to the CBAT and the MPC.
Right.
So the discovery observations have already been sent. So, but yes, you tell the other members. Well, not everybody does. Not everybody does. Some people don't. But I personally do. Because if it's a Comet, I rather have the other person go with like an extra 30-second exposure, and clearly see the tail in the same position angle or not.
Right.
So yeah.
Do you sometimes have all 4 telescopes working the same night with 4 different observers? The Bach telescope, the
It happens. So the Schmidt telescope and the G96, they are always, and the 1 meter, they're always working all night. So whenever we have the Bach time or Kacper time, it happens that we'll have 5 people, at the mountains.
So who decides who gets what telescope on any given night?
So we have a schedule, a schedule for each nation, which is crafted by our PI, Eric Christensen. So he makes a schedule, tries to rotate us, make sure that everybody gets equal amount of, telescope, because, there's some telescopes that are more popular than others,
Okay, what's more popular?
Well, of course, the 60. G96. Okay. Yes, because that's what we call the big chair. You're at the big chair tonight, so the 60 observer can ask other observer to, hey, would you do a follow up on this? Because I lost it, or it's not like the lead, like the shift lead or anything, but you could think of it that way. It's okay. The person at the 60s, because that's where more things are at stake.
Could you just quickly go through the list of who the observers are in your team right now?
Yes. So we have. Oh, hold on. I was going to do it in alphabetical order, but I probably shouldn't. So you have David Rankin, Alessandra Serrano, Joshua Hogan, Jacqueline Fazekas, Hannes Groller, Richard Kowalski, Greg Leonard, wait, who am I forgetting?
Is Andreas Boattini still with you or not?
No, not with us. Not with us. Wait, did I just?
Is Brian still there?
No.
Brian
no.
left.
Yeah. I'm quickly checking on the.
Okay, but there are about 8 of you or 9 of you.
Yeah,
what about
8 or 9.
Carson? Is Carson?
Oh, thank you. Oh my God. Sorry, Carson. Sorry if you hear this. Yes, Carson Fools, of course. Yes. So that's what you could call the core observing team. Some of us full time, some of us are 2/3 time and do other daytime projects. But that's the core team. But then, of course, we have people like Eric Christensen, who has been with us for a very long time. So he will observe every now and then. Same with Alex Gibbs. He will observe from now and then. Yeah.
And then you've got members who don't observe.
Yes, yes, and they are crucial. It's our our engineers, our daytime, the daytime crew. Without them, we wouldn't be finding stuff.
Want to give them a shout out as well?
Yes, of course. So Frank Shelley, Rob Seaman, Don Fay. you guys are putting me on the spot because there's like 17 of us, and
That's a huge team.
Al Grauer. Who else we have? Well, Eric Christensen, of course. Alex Gibbs.
I remember when Catalina was four of us.
Yeah, there's like 16 of us.
Of course, we only had one telescope back.
So it's really it's in a way it's beautiful because it is a team effort, but it's a team effort. The day crew enable us to do the job that we do at night, but then at night it's you, the telescope, and the sky, and that is an aspect that I like and that I specifically wanted whenever I joined CSS. There's something poetic, almost romantic about the idea, that you are at the top of the mountain doing these things alone.
So Kacper, do you actually drive up in the mountains in the expectation of discoveries, or has it become routine? I mean, is it still exciting for you going up every night, or how is that?
It's exciting whenever I look at the forecast and I know that my shift will be clear. If I look at the forecast and I see that I will be under the clouds for 5 days or a week, then I go like, geez, I'm going to be stuck here at this mountain and I won't even be able to open the dome, So then it's not fun. But whenever it's clear, yes, I drive with expectations, and especially when you open the dome, and it's clear, you'll find stuff at the 60, So yeah, it's the best moment of the night for me, when you're opening the dome.
So I have a feeling that you, in particular, when you see a fuzzy object coming up that's new on an image, that you're excited about it when you see that.
So I'm very grateful for one of our software engineers, our main software engineer, Frank Shelley, because he has tweaked our pipeline right now. So known comets are auto-identified using, NPC ephemeris. So they show in the images when you validate it, and you have like the name. This is a new change. Like 9 months ago, that didn't happen. So every single comet that we saw was like, oh my god, and we had to run all of the pertinent checks, So my cardiovascular health has improved greatly ever since known comets are identified, because I don't get that excited, especially when you're in your last set of the night early, in the morning sky at low elongation, and you see this like magnitude 19 thing. I was like, come on, there's gotta be new. It's gotta be new. And it's like, okay, 2p Enki. Like that happened to me last week, Like, okay, this is like one of the oldest ones. But I get very excited when I see something fuzzy and faint. Because if I see something fuzzy and bright, I'm like, yeah, someone else has got it already,
Hey, Kacper, does Catalina follow up on other people's potential discoveries?
Oh, yes, we certainly do. Whenever they are on the near Earth object confirmation page, we follow up. We follow up objects from the near Earth confirmation page and also single operation NEOS based on the suggestion of NEO broker that we've developed over the past years. It's been in the works for years and years, and it's called NEO Fixer, and anybody can use it. It's free, and it's extremely useful and very, very advanced. It takes into account like the cost of an observation from your observatory, because it knows how big your telescope is, the potential benefit of your observations in terms of reduction in uncertainty in the orbital elements. It's very advanced, and I recommend to anybody who's doing follow-up of near-Earth objects to give it a try.
So, Kacper, you have 4 comets that are named for you now. Is that right?
Yes, that is correct. Yes.
Okay. Can you tell us anything special about those discoveries, and does any one have more meaning to you than the others?
The first one has the most meaning, because I dreamed of that for years, you know. I was like, I dreamed of that moment, you know, like what would I be wearing, you know, like it's really silly, I know, and it's really silly because we're talking about a magnitude 18 moving speck, you know, but I don't know, it was my dream, and dreams don't need to be rationalized, right? So
Right.
in my case, it was a fantastic moment. Like my hands got super sweaty when I typed the activity form, and I couldn't sleep the next day because of course I slept during the day, work at night. So I was like, oh my gosh. As soon as it got a little bit of a few follow-up observations, I started filtering objects using the JPL small body database. So I downloaded like all the orbits that could match the orbit of my object, including uncertainties, to see if it's a potential recovery of a null. Anyway, so yeah, I was very nervous, you know, doing all of these things, thinking, oh, is it new or is it a recovery of a periodic object that has drifted away?
Yeah.
So
that happens a lot. We're getting a lot of accidental recoveries of short period comets that have only been observed at one apparition.
Yeah. So yeah, that was April 25th, 2020, I remember. And I was very fortunate that it took only 3 days for the official release of the CBET and the MPEG announcing the object. So I didn't have to suffer, you know, for 2 weeks. I don't know if I would have taken, so only 3 days. And yeah, it was like I was in a state of bliss and nirvana for the next few weeks. So that was the most special. Other fun things. I think the third one that I found, that's P2021U1. That one I burned some food because the control room has a kitchen, so I was just like sending the reports, like looking at the pixels, like is it really like, and food was burning.
You were cooking something on the stove at the same time?
Yeah.
That's a good story.
But it was worth it. It was fine. I wasn't that hungry anyway. Yeah, it's exciting. I still get excited by the idea, of the possibility of finding a bright one. Like I don't ask much. I don't ask for a naked eye one, but if I could find one that I can get to see through one of my telescopes, that's what I want.
I can't wait for you to find a bright naked eye comet and you have the press coming to you and asking you how to pronounce your last name.
Oh gosh, that would be a really fun.
Yeah, I can see on the ABC Nightly News they're going to try to pronounce that, and they're going to say, we're going to let Kacper do it.
Yeah, like what is that? Is that someone's Wi-Fi password? A W, an R, and Z?
Were all your discoveries with the Mount Lemon scope?
Yeah.
Like you mentioned before, you're probably a little more excited when you go to the 1.5 meter versus the 0.7 meter.
Oh yeah, no doubt, for sure. Yeah.
How many comets does the Schmidt find now? It's compared to the Lemon scope.
Very few. We were averaging one a year for the past 3, 4, I'd say even 5 years. So very, very few and far in between. Yeah, I do suspect that is because Atlas has gotten very good at finding comets that are relatively bright. So we're talking magnitude 18, 17, 19.
But they don't know it when they find them.
But that are stationary. That's the thing. Atlas has gotten very good at finding objects that are stationary. I believe it's because of their supernova pipeline. So our pipeline is very well fine-tuned for NEOs, for fast-moving objects. So it does happen that, we have new comets in our images, but they're just moving too slow, for our moving object detection pipeline to pick them up. Yeah.
So Mike Meyer had a question for you, and I'm going to read that to him. Unfortunately, he couldn't be with us tonight, but he was asking if if you see your surveys as being affected by climate change and effects of civilization, like wildfires, light pollution, etc.
Yeah, good question. So you see, I think those changes are perhaps on, as you mentioned, it's climate change, right? And climate is usually defined over longer time scales. And I've been with the survey for 4 years, So me personally, ever since I've seen any differences. I have seen that monsoons are different each year, 2020, the monsoon didn't even come. That's why we had that record. We broke the record of finding over 1,500 NEOs, Wildfires are a big problem where we are. Every few years we have a bad wildfire, and we have to close operations, and the air smells like smoke, and it's bad. So yeah, that's unfortunately, I hope I'm wrong, but things could get wrong. Things could get worse with climate change.
Yeah, I think I might just ask Carl a question here, because Carl's been there a lot longer than you have. Like, Carl, have you seen the light pollution get a lot worse there at Catalina, Mount Lemmon?
A little bit worse. Even on Mount Graham, you can see light domes that you couldn't see 20 years ago. Though part of that is because a lot of the trees burned down in the fires. But yeah, after I've been observing on top of Lemmon and Bigelow for about 30 years now, and the sky's a little brighter. Definitely the fires were a problem. The contrails have become a huge problem. I don't remember it being quite as cloudy back then as it is now. Not rain clouds, but just kind of cirrus all the time.
And airplane contrails?
Well, because the telescopes here are kind of directly under that Dallas to LA route.
Oh, yeah.
So you do get a lot of airplane contrails.
Yeah.
I don't know if that's something you notice, Kacper, when you're up there.
Yeah, we have quite a bit of contrails, especially during the evening for some reason. Yeah. But I don't have like a comparison, how it was 20 years ago.
Yeah. I'll just point out, Kacper, that now I observe from, at least do my imaging, from a coastal valley in California. And over the last year and a half, I've noticed an extremely significant increase in relative humidity.
Mm.
And even during the summer, when we're supposed to have, dry heat, it's not dry anymore.
Huh.
And that has resulted in me not doing a lot of morning observations, because being in the valley, temperature drops and the relative humidity goes up, and it becomes drippy wet. So just point that out.
Yeah, even our monsoons here have changed. I mean, the old days, I remember getting observing runs in July. Me and Tim Spar, before Catalina, when it was still Bigelow Sky Survey. Because we weren't in school, we would get a week or two in July. And during the day it would rain, you have your thunderstorms, you have lightning shut down. But then by about 10 or 11, it would clear up and you would observe for the rest of the night. Now it seems like the monsoons, you've got a lot more moisture and humidity, but less rain. It's like there's a lot more, moisture in the air, but the air is less efficient, more stable, so it's less efficient to actually making rain. And so now you've got clouds almost all night long, it seems. The debris clouds from the various storms.
It is that my experience is that during monsoon you have clouds, debris clouds throughout the night. Sometimes you might get lucky and it might clear towards the end of the night.
Yeah.
That's the moment where I guess you might get lucky, but monsoon is hard.
So what do you call the monsoon season in southern Arizona? Is that like June to August?
I believe it's, I don't know like what the official date is.
The official is June 15 to maybe September 1. Usually early July sometime it starts, and it runs to August. It can go all the way to September, October if it's an El Nino year and we get hurricanes up here.
Which I believe this is an El Nino year.
Right. So this could be a late starting monsoon, which it appears to be, but also could be a late ending monsoon. So we'll have to see.
Yeah, the worst part about monsoon is, so we usually stop operations during monsoon, and we do daytime tasks, refurbishing hardware, cleaning up the sites a little bit. We'll have a kind of like a monsoon project. But sometimes we observe. So, for example, we stopped observing, I believe yesterday was our last night of observing. And during those nights that monsoon has already started and you're at the telescope, they're quite tiring because you have to do a lot of lightning shutdowns and lightning startups. And those are, because if there's lightning, that could damage your camera, and the camera is worth,
Those shutdowns are stressful.
Yeah.
Especially when the storm sneaks up on you.
Yeah.
Hey, Kacper, are any of the Catalina data available publicly online?
Yes. So this year, actually, our senior data engineer, Rob Seaman, started a project of uploading it to the PDS. So the data is being uploaded to the PDS. I know there's several years worth of data already in the PDS, but I don't know how the backlog looks like. I don't know exactly, when it starts, when it ends, but I know that our data is already in the PDS and it's in the process of completion of having all of the data. That's the goal.
That's interesting. I think Sam Dean will be very interested in that. I think you know who Sam Dean is.
Yes.
We've all come to know who he is lately, and he and Kay Lee and a few other people are really starting to comb through all the publicly accessible data from telescopes around the world, and they're finding a lot of very interesting information, especially dealing with comets and extending the arc. That's very interesting.
Yeah.
So for a while in the early 2000s, Catalina had another survey, the Siding Spring survey, which was down in Australia with Rob McNaught and Gordon Garrod using the 1.5 meter Schmitz down there. Are there any plans for Catalina to expand back into the Southern Hemisphere?
Unfortunately, as far as I know, no. Not as far as I know. It would be great, but, we're about to have the mother of all surveys in the Southern Hemisphere, right?
Yeah.
The Vera Rubin Observatory. So I don't know, to which point that would make sense right now. It'd be great, because they were very productive,
Oh yeah, especially comets.
Yeah.
I guess Atlas is getting those comets now.
Right. Yeah. To me, I've been so amazed that the Southern Hemisphere has been so devoid of big survey telescopes since since Rob McNaught's survey went offline. Until the last year. Now that Atlas has one in Chile and one in South Africa. But it's just there was a huge void there for a long time.
Yeah, and it's a void that lots of amateurs were able to to take advantage, and rightfully so. We have some amateur run surveys that have been quite successful.
It's going to be a lot harder for amateurs now, especially with the LSST coming online.
Yeah.
Yep, and then eventually NEO Surveyor in space.
Yeah. So are you working on studies of specific comets still, other than your survey work, like you were doing with your PhD work?
Yeah, I still have some data that I am working on from Comet C 2016 R2 Pan-STARRS, particularly. The chemical composition of that comet was so unusual.
Walk us through a little bit of that. About this is a CO dominated comet. Just tell us a little bit about that.
Yes. So, well, as most of the listeners will know, a comet is an object in the solar system with a nucleus ranging from a few hundred meters to several kilometers, and it's got a lot of ices in it. It's got a very low density. In fact, if you put a comet in the ocean, it would float. So it's a very porous and icy object. So whenever that object approaches the sun, those ices start sublimating, and that's what we see as coma, that gaseous envelope. And whenever it interacts with solar wind, that's what we see a tail. It's a very high-level definition of what a comet is. Now, those ices in the comet nucleus, are the clue to its activity. The main activity is water ice. So most of the comets that we see, whenever they have a gaseous coma and or gaseous tail, to a big degree, I'm not saying it's only, but to a big degree, it's generated by water ice. Now, there are a few comets that have some very strange chemical composition. Well, every comet is strange in its own way, and I always like to say that if you look deep enough, you'll probably find gold in a comet, a few parts per million, but you'll find there. It's just how deep you look, right? So there are a few comets that seem to be CO dominated, so basically carbon monoxide. Those comets actually tend to be blue, tend to have blue appearance to the human eye in visible light, and that is due to ionized carbon monoxide. It has that blue color to it. So there are three comets in the last 100 years: Comet Morehouse, Comet Humason, and this comet C 2016 R2 Pan-STARRS that were very, very CO dominated. Of course, whenever such a comet approaches the solar system, when such a comet approaches the sun, you can see all sorts of interesting tail and coma morphologies. The tail kind of like closing up on itself, or like little spirals in the tail, which I heard is called the corkscrew effect, and the Christmas tree effect, like some funny things going on. So yeah, those comets seem to be outliers. Could it be because they were formed in a different region of the solar system where volatiles, because obviously carbon monoxide is what we call a hypervolatile, because it's much more volatile than water. So could it be formed in a part of the solar system where some hypervolatiles like carbon monoxide or molecular nitrogen were shielded? I don't know. So there's a lot of science to be learned from this CO-dominated comets. We also have another comet, perhaps the most interesting comet of them all, which is 29P Strassmann-Wachmann 1, which it's bizarre. It's a very large comet. It's a periodic comet. From an orbital point of view, it sits somewhere between a Jupiter family comet and a Centaur, and it's got a continuous but variable CO emission. What do I mean by that? I mean that wherever you look at that comet, you will find CO, you will find carbon monoxide, but in different quantities. You can have CO outbursts. You can have moments where the CO is at what we call the quiescent stage. So, well, it's called the baseline stage. And yeah, it's quite a bizarre comet. Of course, I should point out that in order to observe CO, at least neutral carbon monoxide, you need to do it with millimeter or submillimeter wave spectroscopy, which is radio astronomy, because the mechanism of emission of neutral CO is through rotational emission. It's not the normal electronic transition that we all know, that you have an electron jumping from a lower or a higher level in an atom. So Yeah, so in order to observe CO, you would need a radio telescope to observe that 115 or 230 gigahertz band.
Kacper, are you familiar with Richard Miles' work on 29P? He's with the BAA.
Yes, of course. I'm familiar with his work. I cited his work in my work. He cited my work in his work. Yes, very interesting work, and it's amazing that he's doing this long-term monitoring campaign of 29P. And I think that is one of the that's one of the clues to the mystery. To resolve the mystery of what on earth is going on with 29P, we need multi-wavelength monitoring. This is going to be a shameless self-promotion, but one of my works about 29P, I think I published it in 2020 or something like that. What I did is basically monitor the activity of the comet through its carbon monoxide emission, that is with a radio telescope, with a 10-meter submillimeter telescope here in Monogram. And I also used data from amateurs from different parts of the world that were monitoring the comet in the visual part of the spectrum. So basically what I noticed is that the CO outbursts of that comet, which you cannot see. You cannot see the CO outburst because remember, CO is it's submillimeter wavelength, and the visible outburst, that is the outburst that you can see, or in other words, the dust outburst, because that's what we see mostly in that comet, are not correlated. So that's so strange that the hypervolatile gas that to a big extent is responsible for activity in that comet is not correlated with the episodes of activity that we can see.
So do you see outbursts in CO at?
Oh yeah.
But are they? You say they're not correlated at all with the visual outbursts.
Yes. So the sampling in that work, like of course, to get CO observations, you need, a 10-meter, 12-meter radio telescope, which is, not always easy to get time on. So right. My sampling for CO was not as complete as I would have liked it. But yes, I can definitely say that the correlation between CO outbursts and dust or visible outbursts is not straightforward. It's not like one goes up, the other one goes up, one goes down, the other one goes down. And what do I mean by a CO outburst? What I mean by a CO outburst is just that if the baseline carbon monoxide production rate of 29P is somewhere between 3 and 5 times 10 to the 28 molecules per second, what I mean is that quantity can, increase significantly, triple sometimes.
I wanted to ask you about the radio observations. I'm assuming you don't have a lot of resolution and that you're just seeing the comet, quote unquote. Can you detect anything further out from the nucleus, or is it just sort of in the nucleus? I ask because in one of the last major outbursts a year and a half ago, I followed the coma going out more than 11 arc minutes in diameter. And so I was just curious if your CO observations, because of the limitations of the radio telescope, are just sort of the comet, or is it something, can you look at various parts of the comet?
Yes, good question. So a radio telescope is basically a 1-pixel spectrograph. As sad as it sounds, with a radio telescope, you basically point it towards the nucleus of a comet and you get an emission line. If you want to take an image, what you would have to do is take a map. That is, point at the nucleus, point here, point, let's say 10 arc seconds to the right, positive in right ascension, then point 10 arc seconds up in declination and do like a spiral. The simplest map is the 3x3 map. So you can envision it like it's a really sad picture, a picture made out of 9 pixels, and the central one will probably brighter, and the ones around will probably fainter. You could also do a 5x5 map, so a 25 pixel image. So with radio telescopes, you can just point at the source and get a signal. In this case, if the receiver that you're using in that is in the 115 or 230 gigahertz range. But if you want an image, you would have to do a map. The alternative, obviously, is if you have a lot of radio telescopes, a lot of antennas, is to radio interferometry. Mm-hmm. And that is what ALMA is capable of doing. But yeah, with
did you ever try to
the work that I did with, I tried and I was not successful.
Well, let me ask the question another way.
It's very difficult.
Let me ask my question another way. When you point the radio telescope, what area of the sky does that actually cover?
Yes, so the area of the sky that it covers, it depends on the frequency and the diameter of the dish. So we are looking at, with the 10-meter SMT, at that frequency, if I remember correctly, it's around 32 arc seconds. So it's a circle, 32 arc seconds in diameter, and that's where you get your signal from.
I suppose that interferometric radio telescopes are the people that operate them and deal with observing time give comets very low priority.
Yeah, they don't give them a lot of priority, but there are some people that have done it. It's interferometry is very complicated. Radio interferometry is, I find it very complicated, but yeah, there are some people that have been successful in obtaining observations of comets with ALMA. Martin Cordiner, he's published a lot of good works with ALMA and comets.
Okay. What have we left undiscussed, Kacper? Tell us any other thoughts that you have about comets, the things that you would like to see done, any future plans, ideas?
Well, things that I would like to see done. I think that following comets at the different wavelengths, it's a very interesting idea that hasn't been done a lot. Of course, it requires the use of many resources, but there's a lot that we can learn. A lot of physics we can learn from observing comets simultaneously at the different wavelengths, because it's just the nature of the physical-chemical processes that occur within the comet are nuclei and coma. Some of them are invisible, some of them are, radio, some of them are infrared. So
I think you've seen a lot of that done with the super bright comets, where you'll get a lot of interest and you get a lot of observation at different wavelengths, but people aren't generally coordinating them. They're generally just everybody's doing their thing, and they aren't maybe all on the same night or in the same week or even the same month.
Yeah, that is true. Yeah.
Even with the International Halley Watch, they weren't coordinating anything. They were just collecting data. I was right in the middle of that, and all these observers went off and did their own thing pretty much.
Yeah. Well, Kacper, you're probably going to be around to see Halley's Comet in 2061. The rest of us were a little iffy.
I'm hoping. That's the reason why I quit smoking 10 years ago. So
Good choice.
If I don't see it, I will be very, very disappointed.
Yeah. Good. Okay, well, Kacper, it's been great talking with you. Glad to meet you finally. I've had so much email contact with you, of course, over the years, and it's a pleasure to meet you, and it's a pleasure to welcome you to the YouTube ICQ team. We look forward to your input with future interviews and maybe even news videos and things in the future.
Thank you so much. It's been an honor for me to be part of this. I've been following your channel, and I'm here giving an interview, so this is great for me. Thank you, gentlemen.
Okay.